Pandas is a powerful data manipulation and data analysis library available in Python. If you're an aspiring data engineer, data scientist, or analyst, you definitely need to know Pandas. I use it almost every single day, and I love how flexible it is and how much I can get done with it. Hey folks, my name is Trent, and in this video, I want to take you through the basics of Pandas. We'll do this by showing you how to do basic data inspection in Pandas and how to perform analysis using the Pandas library. To do this, I'm going to be using a dataset on video game sales throughout the years. I got hold of this dataset on Kaggle, and I thought it was pretty cool and could be pretty fun to explore in Pandas. I think the best way to learn this is by doing, so let's jump right into it. The dataset we're going to be using is this video game sales dataset that I came across on Kaggle. I'll leave a link to it down in the description. Effectively, it's a dataset which shows different video game sales per year, per platform, per genre, and per different regions. For example, showing you the different sales in North America, Europe, Japan, other regions, and then the sum total of global sales. Just as a note, this dataset only lists video games with greater than 100,000 copies sold in that particular year. As another note, this seems to only go up to 2020, and even then the data looked a little bit janky at about the 2020 mark. But for our purposes, I think it's a pretty cool data set. So what you're going to want to do is download this data set and decompress the CSV. I'm going to jump over into VS Code to start our analysis. Over here, I've just got sales data that I just showed you as vgsales.csv. In this folder I've called data. I've also got a bare bones notebook over here, Python notebook, called video game _ sales _ analysis.ipynb. If you're unfamiliar with setting up notebooks in VS Code or you want to match the setup, I actually have a video on that if you want to check that out. Cool. So to start things off, you are going to want to get hold of Pandas. To do that, all you're going to want to do is pip install Pandas. All right, you can see that my requirement is already satisfied because I have Pandas already installed. To start things off, we're going to need to import Pandas up at the top here. Now, it's more of a convention to import Pandas as PD. You'll see that abbreviation used in a lot of different contexts. So the typical name is to import Pandas as PD. Then this line over here, I'm just setting an option to display numbers in an easy to read format. You'll see what I mean when we go through the analysis, but this is just some preference that I have. To start things off, we're going to want to run these lines. Once we've got this set up, the first thing we're going to want to do is actually get hold of our data from our CSV file into what we would call a Pandas data frame. This is the core object of Pandas, or core data structure of Pandas that makes it so powerful. You can kind of think of it as a table or an Excel spreadsheet if you're more familiar with that. It is a little more nuanced than that, but for the purposes of this analysis and when you're just starting out, it's perfect to think of it as a table. So to do that, let's add a code block over here. And what we're going to want to do is type in df, our new variable, which is pretty typical. df stands for data frame, but you can call it whatever you like. So we're going to go ahead and assign to df pd.readCSV, since we're dealing with CSV data. But interestingly, you can see a whole bunch of other read methods available for Pandas for all different types of data. For example, SQL data, Parquet data, or even JSON data. Yeah, there's a ton of different read methods available in Pandas, which also makes it super powerful. But we'll stick with the basics, just go with read CSV. Then we're going to want to give it the path to our data. So I'm going to do that saying /data, that's my folder, /vgsales.csv. And simple as that, we can read in our data into a data frame. To inspect the data frame, you can use the method head. And all head does is it gives us a few lines of the first few lines of a data frame. So let's go ahead and run that and see what we get. Great, so the output over here is our tabular data from the vgsales.csv file. You can see all of our columns are here, such as the rank, the name, platform, year, etc. You'll also notice that there is a column of numbers on the left-hand side over here, and this is called an index. By default, Pandas will add an index to your data if you don't specify one. Effectively, it's just a unique identifier for a row in your data frame. The next thing we want to do, or typically what I do, is we want to inspect the data in our data frame at a high level. So let's go over to the section that I have over here called data inspection. Let's add a code block. So the first thing I like to do is actually just take a look at the data types and the size of the data that I'm dealing with. We can do that by using the .info method over here and running that. And you can see this gives us some useful information about the data we are analyzing. So the first thing is to look at how many entries we have. So we have about 16,500. We've got 11 columns, and looking at the different columns, we can see their different data types, such as integer or int64. Object types are usually text data or string-like data, and then float64 over here. We can also see how much memory is being used by this data frame. So it's about 1.4 megabytes. The next thing I like to do is use the df.describe or dataframe.describe method to get a view of the distribution of my data. So to give us a better view, I'm just going to phase myself out for a second there. In this describe output, we can see different information about the data that we've got in our data frame. For example, we can take a look at something like NA sales, which stands for North American sales of video games, and we can see the average. Just as a note, this is in millions, so this is $0.26 million, not $0.26, but you get the idea. Anyway, continuing on, we can see the standard deviation, for example, the 25th percentile, the 50th percentile, 75th percentile, and the maximum value for each of our different numeric columns. You'll notice that this didn't give us all of our columns. Typically, describe only gives us numeric columns by default. If we wanted to see our other columns, which are actually object types, we can do that with the describe method just by adding in an extra argument. So we can use df.describe, then use the keyword include over here, then in square brackets, enter the keyword object and run that. Now we can see our object type columns and some interesting stats about those. So for example, the number of names or the count of the names, the number of unique names, the most frequently occurring name, which happens to be Need for Speed Most Wanted. Not surprising, that was a great video game. And the frequency at which this occurs. So Need for Speed Most Wanted appeared 12 times in this data set. So this has given us a really nice overview of our data. Now what we want to do is dive into some more in-depth analysis using Pandas. To help us out, I've set up some questions that I think would be interesting for us to answer. So to run through the questions, I want to know which video game had the highest sales in 2010, for example, which game genre is most popular in each year, and what are the global sales per year for every single video game. Then finally, what are the sales trends per region over time? All right, let's jump into some more in-depth analysis and start with our very first question. Which video game had the highest sales in 2010? To find the highest selling video game in 2010, the first thing I'm going to do is filter our data for only 2010 data. Let me illustrate to you how to filter data in a data frame. So taking our data frame object, we then use the square bracket notation, and in the square bracket notation, we're going to input a statement that filters our data. So to get 2010, we can enter in data frame again. Then to select a particular column, we use the square brackets again, and a string specifying which column we're talking about. In this case, I want to select the column year, and to filter this, I'm going to set year or declare that year should be equal to 2010. Let's run this and see what we get. Great, we can see that our output only has data from 2010, or so it would seem. If we keep scrolling down, it actually tells us that we have 1,259 rows by all 11 columns of the original data set. So we can clearly see that we have filtered the data. What I'm going to do is assign this to a new data frame, this filtered down data frame, so that I can use that in the next step. So let's call that something like 2010 DF and assign that. Then what I'm going to do is use this 2010 DF and filter it again to get hold of the video game or record that was the top seller for that year. So using our filter notation again, square brackets, we enter in 2010 DF to start building up our statement. We're going to select the column global sales, and we want to find the global sales equal to the maximum of global sales. So to find the maximum of this column that I'm selecting over here, I'm going to use exactly the same statement, global sales. And to find its maximum, all I have to do is use the .max method. Actually, to show that to you, let me grab this, copy that over. Let's just create a temporary code block over here. And I'll just show you what this looks like with the normal data frame or the unfiltered data frame. And that gives us a number output. So you can see just by using the max keyword, I was able to get hold of the maximum. This is, of course, the overall maximum. And really what we're looking for over here is the maximum of global sales in the 2010 data frame over here. So by using this statement, I can actually get hold of the record where global sales is equal to the maximum of global sales in the 2010 data frame. So let's go ahead and run that. And we can see we get our output and have answered our first question. So funnily enough, it was Kinect Adventures for the Xbox 360 that was the highest selling game in 2010, or highest selling globally at least. And we can see global sales amounted to about $21 million, which is insane. I don't think anyone still owns a Kinect. And if you do, good on you. But yeah, this is an interesting result for sure. Alrighty, let's move on to our next question. Which game genre is most popular in each year? All right, let's open up another block of code over here and jump into this one. What I'm going to do for this next question is I'm going to aggregate our data using the group by keyword in Pandas. So let's go through that. I will start by taking our data frame, and I'm going to select a couple of columns out of the data frame. To select multiple columns, we are going to use the square bracket notation, but we can actually give a list of values. So another square bracket, open and close square bracket, to grab multiple columns out of our data. So let me just show you what a select looks like for multiple columns. So if I want year and global sales, and I run that, you can see I've just selected two columns, year and global sales. After selecting these, I now want to aggregate this, and I want to get the max sale value per year. To do that, I will use the group by keyword, and I will specify that I want to group by the year. And to aggregate the data, I'm going to use max. So dot max will give me the maximum of the global sales. Let me run that and show you what that looks like. So this gives us an output. We have the year and the max sale value or max global sale value for that particular year. Now you'll notice that the year column has shifted down over here, and that's because by default, the group by keyword or group by method, should I say, actually sets the group by as the new index for this result over here. So if you remember previously I mentioned that an index is a unique identifier per row of a data frame, and we don't actually want this behavior, and we can bypass it by entering in as index equals false. And if I run that again, this looks more like a typical data frame output, and I prefer to use my data this way. Great, so we've gotten the year, max sales by year. What we actually want is to get the name of the video game that gave us this maximum sale per year. To do that, I'm going to join the original data frame back into this aggregated data frame. To make things a little easier, I'm going to assign this result to a new data frame called max sales by year data frame. And then use this max sales by year data frame dot merge. You can think of merge as just a typical SQL join. There is actually a join keyword in Pandas, but the more typical method to use is merge. It's a little more flexible than join. Alrighty, so what I want to merge this data frame, this max sales by year data frame with, is my original data frame. And I want to select very specific columns from this original data frame. So I'm going to select year, global sales, and the name of the video game. Then I'm going to specify what to join or merge this on year and global sales, and I'm going to perform a left join. I'm actually happy with the suggestion I got over here. So what we've done here is taken our aggregated data frame and merged the original data frame back onto it to get the name of the video game associated with this maximum sale over here. So let's go ahead and run this, see what we get. And we can see we actually get the name of the video game that gave us the maximum global sale. So back in 1980, apparently Asteroids was all the rage, and it made $4.31 million in global sales. We zoom along to a more recent year and something that we're a little more familiar with probably. You can actually see, interestingly, Call of Duty appears twice. Of course, Call of Duty Modern Warfare 3 and then Black Ops. But funnily enough, in 2013 and 2014, Grand Theft Auto 5 was the top selling video game of the year, which is pretty crazy. We have gotten our top selling video game per year. Let's see what our next question is. What are the global sales per year? To take this question, I'm actually going to use the Pandas plotting functionality, which is super powerful. You can use this to visualize your data pretty quickly and easily. So let's jump to the bottom over here, add another code block. We are going to first aggregate our data by year, so group by the year, and get the sum of the global sales. So like we did before, or similar to how we did before, we're going to grab the columns we want, so the year and the global sales. We're going to select those two columns out of our data frame and group by the year again. And we don't want this set as the index, so we want this to be false. Close that up. And this time we want a sum aggregate. So let's take a look at what the result of this is. We can see we get per year the global sales sum for each year in our data frame. Now I'm going to store this result in its own data frame again. So let's say global sales per year df. Now you may think I'm being pretty explicit by naming my data frames such long names, but it really helps out. For longer analysis, it's really useful to have very specific names so that you can identify the different data frames when you're like 1,000 queries deep. So we've got our global sales per year data frame. Now we want to plot global sales per year df. So we're going to take our data frame dot plot. And in this plot, we can specify the kind of plot we want to use. There are multiple kinds of plots available to you in Pandas. In this case, I'm going to use a bar chart as suggested over here. So kind equals bar. Then we're going to specify our X data as year and Y as global sales. And let's give that a run and see what we get. Alrighty, we got a plot, and we can see it is the sum total global sales distributed by year over here and illustrated by these bars. Now, one thing is this is kind of squashed together and this isn't really nice to read. So I want to make this plot a little wider. To change the size of a plot, you can use the keyword fig size and you would give it a tuple of numbers. So open and close brackets, the first number gives a ratio of how wide the plot should be. So you can give it a size of something like 15. And then the second number gives you a proportion of how big the plot should be vertically. So let's specify 5 and 15 and see what that looks like. And that's much better. That's way easier to read. So we can see our distribution. It makes sense that this is going way up over time because there are more video games out there and people spend way more on video games. They've also gotten way more expensive, dare I say, unaffordable as time has gone on. But this actually makes a lot of sense over here. Great, so this gives us an answer to our question that we had about the global sales per year. If you want to make your plot a little nicer looking, there are multiple keywords available in the Pandas plot method. You can use something like ylabel to actually label this y-axis over here. So we want to say, let's say, sales in millions of dollars, like that. You can see that label has now appeared in the on the y-axis over here. If we wanted to give this a title, we could do that too. We could say something like global video game sales over the years, like that. And this gives us a title to our plot to make it a little easier to read if someone were taking a look at our analysis. There are many more options. You can play around with the colors, the styles, but I won't go into that here. We'll keep things pretty straightforward in this video. All right, great. So we are on our last question to answer. Let me scroll the way back up here just to remind myself what the last question was. What are the sales trends per region over time? Okay, great. So the idea behind this question was that in our data frame, let's just take a look at that again using df.head. In our data frame, we have the sales breakdown per region over here. So we've got North American sales, European sales, Japan sales or Japanese sales, and then all other regions over here. And then finally the global sales, which is the sum total of these. What I want to do is plot the sales over time per each region on the same plot, so we can compare them and see how they compare, right? So to do that, let's take our data frame again, so df, and now we want to select each of the columns that we want to see on our plot. So I'm going to use the double square brackets notation again. And to start off, let's go with year, EU sales, and etc. Okay, so I've specified all of the columns that I want. And now I'm going to group by again, group by year, let's get this right, by year as index equals false again. Now we're going to take the sum of sales per year, so let's take the sum, and then plot all of this, dot plot. And I'm just going to specify a fig size just to make this nice and clear. So let's go with 15 and 5 and just run this. Okay, so I've made a mistake. In my plot, I need to specify that x equals year. Nice, there we go. That is what we're looking for. So this shows us multiple lines on the same plot, and we can see it's even given us a legend over here to tell us what the different colors are. And notice I didn't even specify the different colors. Pandas did that for me automatically, which is pretty great. It helps me tell the difference between each of the lines here. So we can see that we've got our global sales. Of course, that's going to be the biggest because it is the sum total of the rest of these lines. But interestingly, we can see North American sales dominating over here, then European sales. Under that, Japanese sales and other sales actually bounce around for the top spot between the two, which is pretty interesting to see. All right, we have answered all of our questions, and I hope this has helped you see some of the analysis capabilities in Pandas. Thanks so much for watching this video. If you like this kind of content, please consider subscribing, liking the video, and I'll see you soon.